SDR 2020. Moving forward, the keynote speech is delivered by one of the eminent researchers, Professor Dr. Shally Awasthi, on the journey of discovery, invention, research and innovation. And it will be chaired by the former Director of Research, Dr. N. Udappa, currently serving as a professor at MCOPS Manipal. May I request Mr. Ravi Prasad, the Vice President of MAHE SRF, to introduce the speaker.
Dr. Shally Awasthi is a professor and head at Department of Pediatrics, King's George Medical University, Lucknow, India. Her area of research interest include pediatric pulmonology, infectious and parasitic diseases, epidemiology with emphasis to clinical trials. She holds affiliations with more than 43 institutions, research networks or councils as advisor, coordinator or member. Some of the important roles include Editor-in-Chief of Clinical Epidemiology and Global Health Journal at reputed Elsevier publishers. She is an elected Fellow of National Academy of Science, Indian Academy of Sciences, the National Academy of Medical Science, and Indian Academy of Pediatrics. She was also an Honorary Fellow of Royal College of Pediatrics and Child Health for 2018. Professor Shally Awasthi has more than 13,000 citations and H-index of 53 to her research credits. She has more than 200 publications in indexed peer-reviewed national or international journals. Some of her major publications in various journals include the Lancet Journal, the Journal of Reproductive Immunology, BMJ Open, eLife Sciences, Clinical Infectious Diseases, Pediatric Pulmonology, etc. She is also the recipient of various awards and fellowships such as Dr. H.P. Dingley Memorial Award 1996, Dr. Bidhan Chandra Roy Award for 2003 and 2004, Amrit Modi Unichem Prize 2010, Basanti Devi Amir Chand Award 2016 by Indian Council of Medical Research India. She also holds one national award for outstanding efforts in science and technology communication through innovative and traditional methods in 2016 by Department of Science and Technology, DST, India. Now, I request Professor Shally Awasthi to take over the platform and deliver her keynote address.
Hello, Rupa, can you see my presentation? Rupa, can you see my presentation?
We cannot see your presentation.
Okay, I'm starting. Okay, can you see it now?
Yes, ma'am.
Okay, thank you very much, Dr. Udappa, for your kind words in introduction. And it's a real pleasure to come to Manipal virtually also. I have interacted with all of you in so many different forums and I have very pleasant memories of your institution. It's a very eminent, prestigious institution and I wish you success. So today I would be talking about journey of discovery, inventions, research and innovation. When you are young and when you are a beginner, perhaps these words are so intermingled that you don't know what is discovery, what is invention, and you tend to get confused. So here I've tried to make an introductory induction into these terms so that your minds understand this and take it forward. Since I'm from medical background, a lot of what I speak will be from medicine, but there will be a very strong flavor of allied sciences, management sciences, so that everyone here today can work as a team, as your Honorable Vice Chancellor was saying, to promote teamwork, to promote collaboration among you all. So let us take the first word, which is discovery. When you talk of discovery, discovery is recognizing something that is already existing. So if you recognize it for the first time, which nobody has found, then you become the discoverer. That's how Christopher Columbus discovered Americas. In the field of medicine, in 1928, it was Alexander Fleming who discovered penicillin, which led to a revolution in the First World War, saving patients and saving lives. But even for discovery, you have to have a scholarly bend of mind, a desire to do something, and most importantly, persistence, perseverance, as told by Dr. Venkatesh in his inaugural address. So from discovery, we go on to next. What is invention? Now, invention is creating something totally new with one's ideas and developments. And in my inaugural address, I told you about robots, inventions of robots, and 50% or so come from Japan and how they invented it. Invention is completely new, but physical materials needed for its production already exist. It is innovated from ideas and experiences of individuals. These individuals could be you, it could be me, the ideas could be yours, they could come from hearing other people speak, jotting down notes as things happen. So one example historic which we know from our school ages, the invention of the light bulb by Thomas Edison. So how do you do invention? If you want to know a simple formula for doing invention, it is the plus, minus, multiply and divide. The four things we do in mathematics. Addition. So if you found something, you can do some creativity in the implementation. So the people had a pencil. Now this is a pencil. If you want to rub, you need an eraser. But they had a pencil with an eraser. Very simple, very useful. In the medical field, it is the endoscope. Now this is the endoscope, and in the endoscope you put it to see in the gut, in the respiratory tract, and inventions came. Seeing was not enough, light was less, so better light. Seeing with a good light was not enough. If there is an area of interest, you should be able to biopsy it. So biopsy needle went. That was not enough. Every time you didn't need to biopsy, you might want to inject a drug. So another port for injection. And that is how addition led to creativity and implementation, and it became beneficial to the patients and to the society. So that is addition. Now besides addition, you could also do subtraction. Now subtraction means you could effectively streamline, minimize. Think about examples in your field. So there's a regular endoscope here, which is put through the mouth of this person, and then it goes and sees the gut of the person. Now when you put it through the mouth, the person starts gagging. So what did they do? They made it smaller, they made it thinner, they put it through the nose. So there was an ease of operation, and with this ease of operation, it was beneficial. Remember, publication, writing papers is not enough. You have to produce a product or produce an end product which is beneficial to the society. So I told you addition, I told you subtraction. Now very interesting is multiplication. Multiplication is equivalent to lateral thinking, creating something different. So 2 into 2 is not 2 plus 2, but it should be more. So 3 into 3 is not 6. 3 into 3 makes it 9. So you have a sonar technology which was used in the Second World War to detect flights as they came, and you would shoot them down. This sonar technology led to ultrasonography, which is growing and growing and growing based on lateral thinking. So as I talk, you must think about examples in your own field where you can put these inventions. Then there is this very interesting division, problem solving by re-evaluation. Many times there are problems. We think nothing can be done. So you have to re-evaluate, rethink, divide your ideas, divide your problems into bits and pieces, solutions into bits and pieces. One example was an example of TRIZ by a Russian inventor, Genrich Altshuler. He provides a practical methodology, a tool set, a knowledge base, a model-based technology for generating innovative solutions for problem solving. Management people are using it. You can think about reading about it. And then there is tips from the United Kingdom. Theory of inventive problem solving. Big theories into it. Perhaps Sometime you could have lecture on problem solving by those who are experts in this field. So here to motivate your thinking, there is a prism of TRIZ. So here you see this is in this box, there is your problem. If you go the traditional approach, you hit the wall, nothing happens. Think of a problem, face it directly, nothing happens. Nothing has been happening for years, so it won't happen today. So you abstract and you conceptualize the problems into bits and pieces. Take the world's ideas and see what problem is, what are similar problems in other places in the world. Then you conceptualize global solutions to similar problems. Global problems like yours, global solutions to problem like yours, trigger specific applications and you get your solution. So you have bypassed the wall. This is the prism of TRIZ. There are principles, there is trends of technical evolution, there is a database technology, standard solution technology, and there are gurus of this which can help you think about it. So what I would like to say is that even if you hit the wall here, don't worry. The hitting the wall should make you think. You have to think lateral. You have to think, you have to grow across so that you can think better. So one mistake could provide opportunities for invention, innovation. One success makes you stop there. So those of you who have failed, don't worry. You are the ones who will invent or have innovations rather than a person who has been successful at the first go. Another example from the medical field. This is about the trans-arterial chemo immobilization. Way back in 1977, another Japanese Yamada found that if there is a cancer in the liver, it is preferentially supplied by one artery. So he said, if I embolize this artery to deliver drugs to the tumor, it will perhaps kill the tumor and it will spare the surrounding liver tissue. That was an idea. He did not immediately succeed, but 10 years later, they found there's a lipidol, a product which can be selectively retained by the cancer cells, some hepatic metastasis of other types of cancers, and then they started popularizing this technology, trans-arterial chemo immobilization, to treat cancer with success. So Yamada found something, innovated something, failed, but this led to improvements and benefits later on. So what is difference between discovery and invention? Now you can answer. Invention can be simply defined as creation of something new through your knowledge, through your hard work, through your skills. Unlike discovery, invention is fabrication of something entirely new, and it can have its own uses. It can have new functions in the modern world. You will benefit society. If you go back into the history, read about history of transportation. They would walk, then they invented the wheel, then they invented the aircraft, then they started going to the moon, so on and so forth. That is the difference between discovery and innovation. So if you put it simply like this, few things I will tell you. I told you discovery is something nobody's found, but what is more important from you is that if you have done an invention, this invention can be patented by the creator. Discovery can't be patented, invention can be patented. And as researchers, the more patents you get, the more patents which go into public domain, the better researcher you are. And that is what was said by your Vice Chancellor. Another thing is that discovery is just chance, whereas invention takes a process of experimentation. And repeatedly, I will tell you that from after discovery, when you go through the path of invention, innovation, research, you have to have a core competency, a dedication, a perseverance, and a desire to do teamwork and excel. So that is the difference between discovery and invention. Now the third word I put was innovation. Invention can be defined as the creation of a product or introduction of a process for a new time. But innovation means that you have invented something, somebody takes it and improves it and makes a significant contribution to the existing product, process or service. So you are the inventor, somebody innovates it so that it becomes user friendly. Someone invented, for example, the microprocessor, but microprocessor was nothing more than a circuit board. But what was done with that piece? Hundreds and thousands of products, processes, services evolved from that microprocessor, and that required innovation. So microprocessor was invented. Subsequently, things were innovated. Innovation is also very good because that takes it into a product and you get credit for innovation. However, you cannot patent innovation because invention has been done by someone else. And perhaps another idea is that for subsequent colloquiums like this, you can understand what can be patented, what can't be patented, and the rules around it. Another example is Steve Jobs, the poster boy of innovation. iPod is cited as an example of innovation, and I'll tell you why. iPod wasn't the first portable music system. There was Sony Walkman. When I went to United States to study my epidemiology, I bought a Walkman. There was no computers were there, but were not so popular. But everyone was with a Walkman. They were taping all the lectures which the professors gave. They went back and heard. I started doing the same thing, but they also heard music. So Walkman was music everywhere, anywhere, anytime. It was conceptualized 22 years earlier. iPod wasn't the first device that put hundreds of songs in your pocket. Even before iPod, there were dozens of manufacturers of MP3 device. iPod was released in 2001. Apple was late in music sharing platform. There were other things also which preceded iTunes, which you all as young generation know better than me. I never knew about Napster and Kazaa, but they were there. So what did this do? Given all these sobering facts, is the iPod's distinction as defining example of innovation warranted? Absolutely. Absolutely. Great innovation. iPod, Apple innovated. It combined all these elements, designed ergonomics, ease of use into a single device, and then tied it up to a platform effortlessly, is keeping it updated with music. That is innovation. So Apple invented nothing. It innovated. It made it easy to use ecosystem, unified music delivery, discovery and device, and revolutionized music industry. So I think with the example of iPod, you understand the difference between invention and innovation. Then what is innovation? Innovation is basically connecting the dots between invention. Spotting the potential for improvement. It cleverly fills a gap in the market and combines inventions into products that will attract customers, generate commercial success. You all are here from management, you are here from computer sciences, you are here from marketing. So innovation is the buzzword. You should think about innovations. So invention creates something new. Innovation creates something that sells, improves the use. So from this, let us see what are the types of innovations? It could be incremental, you build on something existing. It could be radical, absolutely new thing. It could be in a product. It could be in the process. It could be in the business model. It could be in the systems. You set up complementary systems. It could be autonomous, no modification required. It could be open. You exchange ideas with the world, like you write a blog, you put it on a chat box or social media, or your university would be doing a closed invention of the processes, systems, products, and nobody else knows except your company, your university. But in this, with purpose, I did not put innovations in medicine, because now from here on, I will talk about certain innovations in medicine. I'm comfortable talking about it because I'll take 3 small examples from my journey in the field of innovations in medicine. Innovation, remember, is not invention. Therefore, I cannot patent anything. But I was trying to improve delivery of services to the society through my work. First was a trial. This is community-acquired pneumonia. When you get fast breathing and when a child coughs, the child can have community-acquired pneumonia. It was treated with antibiotics of variable duration. Some said 5 days, some said 10 days. It resulted in high cost of treatment because pneumonia is the leading cause of under 5 mortality, and there are many cases in lakhs of pneumonia. And if you give drugs which without a policy, without prevention of antimicrobial resistance idea, it will give rise to emergence of antimicrobial resistance. So the idea was, can you shorten the duration of antibiotic therapy? Do we have examples from other diseases? Yes, we had example from urinary tract infection. So if it could be used in urinary tract infection, can it not be used in community acquired pneumonia? Especially if it is not very severe, especially if it does not require hospitalization of the patient and you can treat the patient on an outpatient basis. So we did a study and we studied what is the effect of 3 days versus 5 days treatment with amoxicillin for non-severe pneumonia. It was a multicentric randomized controlled trial published in BMJ. It is in the clinical research edition of BMJ. And what we found was that yes, 3 days is as good as 5 days. And as a result of our study, as a result of studies done elsewhere in the World Health Organization changed the treatment policy, and now this non-severe or pneumonia as it is called now, because the name also evolves, is treated with 3 days of antibiotic. We saved money, we saved emergence of drug resistance. But having done that, we revisited pneumonia. Programs to prevent deaths from pneumonia are there since 1980s, yet deaths are still persisting. There were same issues. We wanted to see if new issues have come up. Same issues were there. Parents were not recognizing the disease. They knew the name pneumonia. Even when they recognized the disease, they delayed in decision making and going to healthcare provider. When they went to a healthcare provider, they did not go to a qualified provider. They went to a provider with whom they were comfortable, usually in the village, usually close to home, and mostly these were unqualified. So, based on what they told us, we developed IEC material. We developed audio, video, posters, and you can see we have our website fightpneumonia.org. In Hindi, we found out what they are not understanding. We developed, created posters, we had stories, we had messages, and we said, okay, let us tell them. And we validated all these and they understood. Now, if we had stopped our journey here, that would have been not good, because we've developed something, we have validated it works, but the parents understand, but will it work in the real life? So we took it a step ahead and we said, okay, if you use our materials, will the parents' behavior change? And this is called behavior change communication research, operations research. So we used our material, the posters we had developed. We did another innovation and we gave them medicines, as you can see below, in green We packed the medicines in green and yellow. We called it the pneumonia drug kit. And we followed a strategy in which we trained the providers. So we improved the services. We generated demand in the community by sharing these posters with them. So generated demand and improved supply. And when we generated demand for pneumonia, we improved the supply of services from the government sector. What happened was that the community started going to the government providers for care of children with pneumonia, which would translate into reduction in mortality due to pneumonia, because our ultimate goal is to reduce mortality. So this was a package of operations research we did and we tried to innovate systems, processes, services for benefit. A third quick example is now pneumonia deaths are reducing, but newborn deaths are high. Neonatal mortality, NMR is neonatal mortality. 1/3 deaths are due to sepsis. Sepsis in newborns should be treated in the hospital. However, parents are reluctant to take the cases to hospital because there's a mother at home who's just delivered and the grandparents say, who takes a child to the hospital? Or perhaps, let us see what happens to the child, leave it to nature. So, can we treat such children closer to home? Can we simplify treatment? Can the existing health system do it? Simplification of simplified treatment was developed by another set of people. We teamed with them and we gave them simplified oral treatment closer to home. We teamed with the governments and we trained the government. And when we were doing these operation research, we identified 1,300 cases of sepsis, out of which 3/4 of them said we will not go to the hospital, but they accepted simplified oral treatment. When they accepted simplified oral treatment, we treated them with oral amoxicillin plus injection gentamicin. We found that 92% of them who accepted simplified treatment were cured, successfully treated. Only 2.6% died. 25. Now, what if there was no simplified treatment? Perhaps majority or a significant proportion of them would have died. So based on this, the government of India has put simplified treatment into national policy. So from this medical example, I would go into another buzzword which is today. Now we understand what is discovery, we understand invention, we understand innovation, we understand innovation can be done everywhere. Now let us go to another buzzword, artificial intelligence. Everybody is talking about it. Artificial intelligence for COVID recognition, artificial intelligence for what all. And you are positioned in a place where you can maximize use of artificial intelligence. Now, artificial intelligence is use of computers and technologies to simulate intelligent behavior and critical thinking, not new, discovered way back in 1956. But it's coming up now with improvement in computers, with technologies, with people sharing data, shaking hands. So there are machine learning, which some of you must be doing, natural language processing, which we are doing, content extraction, classification from what people speak, translation, Google Translate, which sometimes that does bad translation, expert systems by artificial intelligence, vision, which I'm using, image recognition. This is called in the Google, it is there, Google. When I see a bird or a flower, I put it in the Google Lens and it tells me the name of the flower, name of the bird. Artificial intelligence in speech to text, text to speech, planning and robotics. This is something which is coming up in a big way, and in healthcare, it is really in use in compiling and analyzing medical data. So if you see here, content extraction, classification. This is natural language processing when you come in compiling and analyzing medical records. Performing repetitive jobs, like when you have a CT scan of the thorax, data entry, in radiology, in cardiology. This is repetitive job. If you are tired, you can make mistakes. Then the computer does it. It tells you, okay, I read the CT is saying these are the findings and it gives you output. Okay, perhaps this is COVID, and in COVID it will tell you the grading. In cardiology similarly. Now it has been used in designing treatments. You feed in patient details. It will pull up external research done in this area related with what the patient is suffering from. It will give the patient detail and the external research to a clinician. Clinician will give inputs of his and her opinions, and there will be an individualized treatment plan. Another thing is digital consultation. Apps like Babylon in UK are there for digital consultation. You have virtual nurse like Molly, like Alexa, which monitor patient's condition. They follow up the patient. They ensure that treatment is given between patient visits. There is this app called iCure, smartphone with webcam to check whether you are taking your pills, you are really taking it or spitting it out, and it goes to your database. It's also used in drug creation and discovery, like in Ebola, maybe even in COVID. And there are something new coming up like precision medicine. Those working in genetics, genomics, link disease with DNA. It is linked with body scan to spot cancer, vascular disease early. And what all of us are using is Fitbit, Apple, that red heart on the Apple app for health monitoring, and general healthcare system analysis like for immunization. In pet care, when I had a pet, computer generated that now it's the time for vaccinating your pet. Those sort of things are happening in healthcare by artificial intelligence. So you'll think that I've talked about all these. What will I talk next? I'll talk about all these are happening in healthcare. I've talked to you about all these things which are happening with artificial intelligence. Development, monitoring, managing data, diagnostics, consultation, personalized treatment, health plan, surgery, planning surgery, medical treatment. But there are disadvantages. You lose jobs. You can lose human touch, empathy. Emotional intelligence is lost. You may not be able to factor in patient's preference. In evidence-based medicine, you factor in patient's preferences with the evidence that's there. You can't factor in patient's preference, at least till now, unless you innovate something which factors in patient's preference. And the advantages are efficiency, accuracy, precision, quick, decreases the workload, increases patient free face time. So, you can keep talking to the patient. You're not, working, writing. It increases, it gives us time to focus on critical cases because every patient needs time, but the critical need more time. If we give time to non-critical patient, the critical will suffer. It saves money and you can monitor the patients better. So we have to see where the advantages or the disadvantages, what are there, and we have to make a decision on whether we go this route of artificial intelligence. So this is something which I got from Shutterstock. I like it. See all the 4 things. One domain where, these are all areas where you can work, perhaps. There are known knows, things we are aware of, we are understanding. We know what should be done. We don't know how to do it. We know what has to be done. So that is where you do lateral thinking. You can do innovation. You can follow the TRIS prism and bypass there. Then the other thing is known unknowns, things we are aware of, but we don't understand. We are aware certain things are happening. We don't understand. So it raises questions. Gaps in knowledge are there. We know the gaps. So here we can do research. We can write questions, we can write how we will measure our success, how we will build hypotheses, and how we will go further from there. Then this blue box is unknown knows. Things we understand we are not aware of. For example, in COVID, we know that there is problems, there is hypercoagulability, there may be vasculitis, but we don't know why clearly. Things we understand. So here we should do group sketching, we should work on our intuitions, we should sit together as a team, do brainstorming and come up with researchable ideas, do lateral thinking. And then there are unknown unknowns. We don't know anything. Things we are neither aware of, we don't understand. This is perhaps some discovery will happen. Somebody might do a discovery while doing research or exploration. So keep this in mind. Known knows, unknown knows, known unknowns, and unknown unknowns. So from here, let us think about what should we do. I told you that if you have first where known knows, you have to think linear or lateral, that is your choice. If you think linear, you have to use your logic. You have to follow a step-by-step approach. You have to have a vertical flow down, a planned path, and take it for innovation, because after all, if you don't innovate, you cannot solve the issue. However, if you come to a blind spot and you fail and there's a wall there, think lateral. Do creative thinking. Open your mind to possibilities. You should have agility in problem solving to consider better alternatives or better solutions to the problem you are facing. And that is what you should start thinking. Those of you who are faculties and mentors should understand and promote lateral thinking, creative thinking in students. So allow vertical thinking, but give additional marks, additional scope, additional leverage for a person who's a lateral thinker. So from here I come to what, people were saying she hasn't talked about research. So research is something serious, time consuming, it's a passion, it requires perseverance. You have to have a position in your organization, whether it's a research officer or a research dean when you do it. So research is not search, you won't search. If you are an expert, you will do a research. For a search, don't need qualification. Your goal in research is to uncover new information, add gaps in the knowledge, fill gaps in the knowledge. Search, you find something new, you've hidden a treasure, you find the treasure, that's your search. Duration of research is long, search is short, process has steps, stages. Now remember, when you are doing research, in conventional research, you go steps and stages. You are by and large doing linear work. If you want to go lateral in research, then that becomes operations research, that becomes health service research, where you can modify and document what you are modifying. There are regulations in research, it is monitored and regulated, and there is interdependence on search results. You search something, then research, you are interdependent, but search is not dependent on anything. So this is a diagram which I want you all to see. In this diagram, there is primary medical research. This primary medical research could be basic laboratory research. Those of you who are in the laboratory, whether it is medical, non-medical, that's fine. It could be clinical for clinicians. It could be epidemiological for those who want to do epidemiological research. Basic research could be applied. It could be theoretical. Applied in animals, biochemistry, cell lines, genomics, pharmacogenomics. Theoretical in wherever you want, like systems analysis, meta-analysis, systematic reviews. You can do method development on how to do things. That is also basic research. But when you come to clinical research, it could be interventional or observational. Interventional could be a clinical study or a trial. Observational could be treatment therapy. How does it work? How would you prognosticate in a patient who has a disease? What are the markers of prognosis? How will you diagnose a condition? Diagnostic study. And you can have case reports, case series. But when you change your lingo, it's just a change of lingo. You go to epidemiological research, you do interventional, it could be in the field or in the group. Like my pneumonia study was in the group field, it was epidemiological, open labeled behavioral trial. And in the observational, now when you talk about epidemiology, you talk about designs, cohort, case control, cross-sectional. So when you are doing a diagnostic study, you can adopt a cohort design. When you are doing a therapeutic study, you can adopt a case control. In a prognosis, you can have case control, you can have cross-sectional. However, so in an observational study, your output would be therapy, prognosis. In a clinical study, therapy, prognosis, diagnosis. But the design could be one of the epidemiological designs which suits your clinical study. So you have to have a core competency in the research methodology. If you combine everything, it becomes a research methodology. And if you have competency in research methodology, you can do your research. But to begin your research, you have to have a research topic. You have to identify a broad area where you want to do your research, whether it's medicine, whether it's non-medicine, whether it's engineering, whether it's management. You have to have a broad area. Okay, I would want to work in telecommunication, telemedicine, or in drug pricing, or in drug delivery system. Then you narrow down to find your niche. Where can you work? That niche will be based upon your core competency, your personal liking, what you can do in the setting you are in, and who are the people around you who can help you. Then you identify a research problem, and I see you have a grant writing session tomorrow. They will help you develop research questions, create a research design to answer them, and write your proposal, which will happen tomorrow. So how to identify area of research is the first thing. Core competency is a must. Whether it's medicine, engineering, management, pharmacy, nursing, genetics, genomics, name it, you have to be competent, par excellence. Then you brainstorm for ideas. Within your core group, within your colleagues, within sessions like this, you catch hold of people and talk about ideas. Choose a topic that will enable you to understand and read literature. Don't choose a fancy topic. For example, if I start working on artificial intelligence, I will fail. I will work on my core competency, but I will read, but I will only do research in where I am competent. Ensure that topic is manageable, material is available. Don't do on a topic where you don't have material in India. Make a list of keywords from that topic. You know, you must be competent in all the words which you use in your research. Be flexible. If this doesn't work, that works before you finalize. Define your topic on a research topic. Read more. Formulate a hypothesis statement and then go forward. I'm happy to see that you all are presenting research works. I heard perhaps you're presenting 300 or so research works in 2 days. That's voluminous. You hear those sessions which are of interest to you. Hear them carefully. See what they did well and find what you can do better in all the presentations you sit with. Because you know, everyone says, and even I repeat it, nobody's ever done a perfect study. So when your colleagues present and you find gaps, then it is for you to fill those gaps. Thank them for leaving gaps in your study. So these are some pearls as I come towards the end of my talk. Have a role model, somebody you want to emulate, someone who inspires you. Have a mentor. A mentor could be close in your institution, that would be best. You can have more than one mentor. Understand what is the purpose of that mentor. That mentor is not do all be all for you. Each mentor has a purpose, a specific, and you and the mentor understand each other's expectations. Form peer groups, your peer groups. They may be critical. Sometimes they may pull you down. So what? Form a peer group. Communicate with each other. Today, communication is so simple. On WhatsApp, on chat, on blog. I mean, you know much more about communicating platforms than I do. Read genuine material, validated material. Be sure that you are reading not opinions that can sway you on the wrong side, opinions that have been vetted by experts. So publications and reliable sources. However, publication and reliable sources can also have flaws in methods and interpretation. So analyze, assimilate, reflect, and most importantly, have a path for your self-development and have a focus that 5 years from now, 10 years from now, where do you see yourself? What do you want to do with yourself? How do you want people to remember you, know you for what? Okay, so with these few things, I have taken you through the journey, but before telling you, ending, I would like to say you have to publish whatever you do. Because having done everything, if you don't publish, it's like throwing your hard work into garbage. Publication makes your efforts permanent. It enters to the body of knowledge. And your paper can be a basis for others to improve. Your paper can be a basis for others to work further. So if the person, Yamada, had not published about his hepatic artery embolization, subsequently people would not have taken it forward. And your work becomes trustworthy, you build your CV, and you build your credibility among peers. So with these few words, I have to caution you that when you publish, if you become an avid researcher, do not fabricate, do not falsify, do not plagiarize. Fabrication, falsification, plagiarism is a big no-no. It will kill your path to credibility and credible researcher. Don't do this. So I end with thanking you for your attention. I bring you greetings from my university, and I really thank the management of MAHE for allowing me to speak to you all today on a topic so close to my heart. I hope you find it useful, and some of you might take home things which may benefit you in the long run. Thank you very much.
Thank you, ma'am. I now request Dr. N. Udupa to provide the concluding remarks.
Thank you, Dr. Awasthi. For the last 1 hour, Dr. Shally Awasthi from King George Medical University, Lucknow, and also she is a MAHE Advisory Committee member for research. She has nicely narrated, and starting from discovery to interdisciplinary research, inventions versus innovation, and also for affordable discovery, and also about data analysis, creative invention, and also about problem solving required, arterial chemo embolization test technology, discovery versus invention, and also the importance of the patenting of the various inventions, and also the importance of innovation like a microprocessor. Then she narrated nicely about innovation of medicines, and particularly she shared her experience of discovering antibiotics treatment for pneumonia, which is affordable, and it has become a national treatment policy. And also she has thrown light on behavioral change about the communications, and also narrated very well about simplified treatment methodology. And in the last, she has mentioned very clearly how artificial intelligence and other technologies are very helpful in health and other researchers and for community treatments, and about medicine learning, language learning, speech planning, analytical methodology, digital communication, treatment design, virtual nursing procedures, medication management, drug creation, precision medicine, health monitoring analysis, healthcare system management, evidence-based medicine. All these things nicely she has narrated, and also she has told for research how gap analysis, hypothesis writing, and also for the present situation of COVID-like diseases, how solutions are to be found, and also how the lateral thinking, creative thinking, and other methods like systemic analysis, method analysis, and she has also illustrated how pharmacogenomics, interventional research, and also about the diagnostic case studies, and also how epidemiology is very important in the healthcare system. And she has clearly told that for research is passion and perseverance, and also analytical thinking and finding gap analysis, and also knowledge creation is very important. She has also very nicely illustrated how cohort design and other methods, treatment problems can be solved by various innovative methods, and she has nicely mentioned and how we have to show our competency in research, and to the young youth who are the future of our nation and world. They are the world leaders. For them, how the research is important, and particularly for technical, medical, health sciences, and pharmacy, all professions in the university system. All the students are there in all the discipline. For them, all this keynote address is very useful, and for problem solving, how these systems are very important. She has clearly illustrated and narrated, and this particular keynote address is really very useful for this particular conference. And we thank you, madam, for your time, energy, and I think you have very nicely prepared this, and you have delivered it very nicely, so that every one of our students and faculty can we could listen, and we would learn a lot of things, and we'll definitely we will implement these things in our research and other day-to-day activities. Thank you very much, madam. Thank you. And thanks all the delegates and the participants who attended this particular keynote address. Thank you very much. I also thank the organizers, and particularly ICCHR organizing committee members for giving me this opportunity to chair this session. Thank you very much.
Thank you, Dr. Udappa, for the concluding remarks. Thank you, Dr. Shally Awasthi, for a very informative session. Next, we have the first plenary session by Dr. Madhu Veeraraghavan, Director and TAPI Chair from TAPI Management Institute, Manipal, on editorial expectations. I request Dr. Carol